This is problem number 39 from section 8.4. We're asked to evaluate this improper integral. Let's start by rewriting this. We're going to note that it goes to infinity. It's improper that way. But besides that, I don't see any values for v in this interval for which this integrand is not defined. So it's simply going to be the limit as b approaches infinity of the integral from 0 to b of 16 inverse tangent v over 1 plus v squared dv. Now, in this case, we're going to solve this integral using a u substitution, and our u substitution is going to be the inverse tangent of v. Why the inverse tangent of v? Because its derivative, which is 1 over 1 plus v squared dv, shows up right here. And so our rewrite becomes the limit as b approaches infinity of the integral from 0 to b of 16 u du. Oops, I'm sorry, got a problem here. When v is 0, the inverse tangent of 0 is 0. Okay, that's okay. When v is b, that means u, the inverse tangent of b. Now we can go ahead and proceed. It'll be the limit as b approaches infinity of 8 u squared evaluated from 0 to the inverse tangent of b, which is equal to the limit as b approaches infinity of 8 times the inverse tangent of b squared minus 0. Alright, now what happens as b goes to infinity for the inverse tangent of b? Well, you may recall that the tangent curve looks something like this, and the inverse tangent curve, where this is, by the way, this is a negative pi over 2, and this is pi over 2. Well, the inverse tangent curve has upper and lower bounds same way, pi over 2 and negative pi over 2 here, and it goes something like this, this, and that. So what we see is as v goes to infinity, the inverse tangent curve approaches positive pi over 2. So as we apply this limit, we have 8 pi over 2 quantity squared, or we're going to end up with 8 pi squared over 4, or 2 pi squared.